In this video, we're going to look at complex numbers. We looked at imaginary numbers and I in the last two videos. This time we're going to look at complex numbers. Complex numbers can always be written in the form a plus bi, where a and b are real. Okay, so any complex number can be written in this form, even if it looks different to start. You can always get a complex number into this form, a plus bi. A is called the real part, because there's nothing imaginary about it, and then this is called the imaginary part because you've got the I, so it's a coefficient with an I. So for example, we could have 3 plus 5i. Okay, so 3 and 5 are real numbers, 3 plus 5i. We could have 2 minus 1/3 I. Okay, you see the two numbers there, a plus bi or a minus bi. We could have negative 7 plus I. Like that. This time the coefficient is just a 1. So those are complex numbers. Those are the kind of things that we're going to be looking at. The other thing that you need to remember that all complex numbers can be written like this. And then from the last video, remember that I squared is equal to negative 1. Okay, that's going to help you get these in the right form. So let's look at a couple of complex numbers in the operations. So addition, subtraction, multiplication, division. So if you add complex numbers, let's say we've got 1 plus 4i, plus 3 minus 2i. Okay, adding complex numbers together is exactly what you would hope it would be. Just like if these were x's, we would put together like terms. So we're going to add the real parts, the 1 and the 3, and we're going to add the imaginary parts, the 4 minus 2i. So 1 plus 3 would give us 4, and 4i minus 2i would give us a positive 2i. So just like if they were x's, you're going to combine like terms and put the numbers together and the i's together. If you have subtraction, let's say we've got 3 plus 2i minus 1 minus 4i. So when you subtract complex numbers, you just have to remember to distribute that negative. That's super important. We've seen that before with some other things. We have to remember to distribute that negative. So we're going to get 3 plus 2i minus 1 plus 4i. Distribute that negative and then combine like terms. So I'm going to have 3 minus 1 is 2, 2i and 4i is 6i. And if you notice, my final answers here are in the form that we want, a plus bi. You're not done until you're in that form. If we want to multiply, okay, let's say we want to multiply, we're going to distribute, just like we would have done with x's or a's or anything like that. So we're going to do 3i times 1, multiply the real parts. 3 times 1 is just 3. And then 3i times 4i, 3 times 4 is 12. I times I is I squared. Okay, so we distribute. Now this isn't in the right form because remember we always get to a plus bi. This is where you have to remember that I squared is negative 1. So we get 3i plus 12 times negative 1. So that would be 3i minus 12. Now here the terms are reversed. That's totally fine. If you want to reverse them the other way, that's okay too. As long as you get down to the real term and the imaginary term, that's the important part right there. Okay, let's try another multiplication one. Let's say this is multiplying imaginary complex. So let's say we multiply two complex numbers. So let's say we've got 2 plus 3i times 4 plus 5i. Okay, this should look familiar to you. Just like if these were x's, we're going to FOIL this out. So we get 2 times 4 is 8. 2 times 5i is 10i. 3i times 4 is 12i. 3i times 5i would be 15i squared. Okay, so we FOIL that out just like if it was x's or a's or b's or anything. Now we can combine like terms just like we've always done. And we get 22i in the middle. Now if these were x's, we would be done right here, but we remember that I squared is equal to negative 1, so we can keep going. 8 plus 22i, this is going to be minus 15. And now we can put the real numbers together. 8 minus 15 would be negative 7 plus 22i. So you've got to keep going until you get it into that right form. Okay, now as long as we're on multiplication, let's look at the complex conjugate. Take that away so it's not confusing. Complex conjugate. We looked at a conjugate before. It was a radical conjugate. And if we multiplied by the conjugate, remember I got rid of the square root or the radical. Complex conjugate does the same thing, and it looks very similar. So if you have a plus bi, the complex conjugate is a minus bi, or vice versa. So you change the sign on the imaginary part, and then when you multiply those together, you get the difference of two squares. So let's look at an example. 1 plus 2i and 1 minus 2i are complex conjugates. Okay, remember the sum and difference terms? You can think of this as difference of two squares, or you can multiply it all out this one time. Let's just go ahead and FOIL it out and see what happens. So we're going to have 1 times 1 is 1. 1 times negative 2i. 1 times positive 2i. And 2i times 2i would be negative 4i squared. Okay, just like we saw before, the middle terms cancel out, and we get 1 minus 4i squared. So the difference of two squares, we get 1 squared minus 2i squared. Okay, difference of two squares, so we can go ahead and skip that first step from now on, difference of two squares. And then we remember that I squared is negative 1. So this is actually going to be 1 plus 4, and that's going to give us 5. So when you multiply a number by its conjugate, you should end up with a real number. No imaginaries in it. Multiply by the conjugate, you get a real number. Let's try another one. Let's say we have 3 minus 2i. The conjugate of that is going to be 3 plus 2i. And let's skip that FOIL step and just go straight to the difference of two squares. So we're going to have 3 squared, which is 9, minus 2i squared, which would be 4i squared. Okay, so 3 squared and 2i squared, difference of two squares. And we remember that I squared is negative 1, so this is going to give us 9 plus 4, and that's equal to 13. So anytime you multiply by the complex conjugate, you should get a real number.